So last we left off, we had the following beautiful animation, visualizing kind of multiplication and modular arithmetic. But it's looking a little bit plain, it's looking a little bit white. I want to add some color. And this is what this video is going to be about. We're going to explore the different things we can do with color in order to just make this even cooler. Okay, very simply, if I want to change color, I know I can just use stroke, right? So I can go before I draw my line, and I can say stroke to define the outline of the line, and I can give it an RGB value, 100, 20, and 40. So 100 red, 20 green, 40 blue. And with that, we get this kind of pink. Okay, looking cool. But maybe I want to do different stuff, right? Maybe I want to make the color of the line dependent on its distance. Okay, maybe I want to make the color of the line dependent on its angle from one point to the next. Maybe I just want to get all of the colors to loop. So I want it to go red, green, blue, and it just loops through all of the different shades in between. So we're very used to RGB, right? Red, green, blue. And pay attention to these numbers over here, which will show you the red, green values. So here I have full red, and as I move a little bit to the right, I increase my green. And then yellow with full red and full green, and then green, and now I'll increase my blue a little bit. Okay, so this is one way of describing colors, right? And everywhere along this grid over here, we get a different RGB value. The new color system I'm wanting to introduce is HSB, hue, saturation, brightness. Now, the way that this color system works, as opposed to RGB, is that it actually works according to angles. So instead of the numbers being 0 to 255, we're now looking from 0 to 360. And you can see at each angle of the circle, we're getting a different color, right? At this particular angle, we're getting red. At this angle, we're getting blue. And as we move further away from the center of the circle, the color becomes more intense. We increase its saturation. As we move close towards the middle, it becomes less intense. We decrease its saturation. So all the way in the middle over here, white, we have a saturation of 0. And all the way at the extreme, we have a saturation of 100. So the colors go from 0 to 360, and saturation goes from like 0 to 100%. Then lastly, we have brightness. Brightness just, it's like the brightness of the entire color wheel. And that as well goes from 0 to 100%. To show this, I have the following cool thing over here. And you can see as I change the angle over here, the hue, I get a different color. And now for each individual color at a particular angle, I can decrease its saturation. And you can see how at 50%, it's less intense. It's closer towards white. And then all the way at 0, it's fully white. All the way at 100, it's this dark or rich blue. The brightness then determines like how bright it is. You can see, okay, we can't really see it right now because it's getting darker, 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 and then it's gone, right? 0% brightness and 100% brightness. So that is how we can do color in this. Let's have a look at how we do that in code. So in order to do code, we first need to tell P5 we're going to be in HSB because by default it uses RGB. So we can say color mode, and I can say HSB. And now this will set the color to that setting. Now this is actually looking at 100 degrees, 20% saturation, 40% brightness. And you can see we get a completely different color. If I go ahead and maybe I make this, I don't know, 200, and I'm going to make this 100% saturation and 100% brightness, we then are going to get a different color. Okay, and now we get this cool blue. Now the cool thing about this is that because it's 360, we can make this cyclical, right? So we can say, okay, go from 0 to 360 and then loop back, 0 to 360, loop back. And we can get the colors to then shift. So what I'm going to do is the following. I'm going to say let hue, because that's what we're playing around with. I'm going to start with 0. And then every time our draw function runs, I'm going to go right to the end here, and I'm going to say hue plus equals 0.1. And then I'm going to define my stroke over here in terms of hue. And now you'll see the colors shift. And as get red, and now we go to like this orange. Okay, looking cool. Here's the challenge though. If I increase my hue, let's say I'm just going to go 10. Okay. So going a little bit quicker now, and it isn't changing anymore. And that's because we're actually over 360, right? So once we get above 360, if we're giving this hue over here a value of 500, 600, 700, stroke is just going to treat it as 360. So we need to actually reset it. So we could do something like this. We can say if hue is greater than 360, we can set hue is equal to 0. And now we will keep the colors kind of shifting throughout it. And now you get this cool kind of flashing. That's one way. Another way we can do it is through modular arithmetic. The exact same thing that we did here with modulus a certain number. So instead of checking 360, I could simply say that the hue plus equals 10. And then I can say maybe something like hue is equal to hue mod 360. And this thing will always make it cyclical. So whatever whenever we get to a hue of, say, I don't know, 380, it's always going to come back because it's based off the modulus arithmetic of 360. So we get a similar effect, okay, and it's flashing. Okay, cool, interesting. We played around the different color thing. We can change how quickly we change this in order to get the colors to appear and reappear at different intervals. But let's try and look at how we can make the colors of each line different based off of their angle and maybe the length. So if we were to find the distance between 2 points, let's have a look at how we can do that. Very simply, right? And you've probably seen this before from coordinate geometry in school. As I move my way around this axis, if I have 2 points, say I have maybe 1 point over here at position 3, 4, and I have another point maybe over here, and we're going to say that's at position -2, 2. The distance between these 2 points, we can just use Pythagoras Theorem, right? Or the distance formula. If we have a triangle that looks like that, we have a right angle triangle. This distance over here from there to there, so this, that is my delta y, right? So that's from there to there, okay, from 4 to 2. And then this distance over here from this point to this point, that's simply my delta x, right, from 3 to -2. And now that's a right angle triangle, so we can simply say the square of delta x plus delta y, or the square root rather, right? So if I say that this is my d, I know my distance is equal to the square root of delta y squared plus delta x squared, just from Pythagoras. And when we simplify that, we get the square root, or if we put it, not simplify, but we put in these kind of coordinates, it's going to be y2 minus y1 squared plus x2 minus x1 squared. All of that under square root. Okay, so that's how we can find the distance from 2 points. So we know how to find the distance between 2 points now, or the length of a line. So let's go ahead and make the color dependent on that. So what I'm going to do is make a function actually to calculate distance. So I'm going to make a function called getDistance. And this function is going to take 4 arguments, x1, x2. Let's actually go x1, y1, x2, y2. That's the way P5 usually does it. And now if I'm wanting the distance between these 2 points, we know we can just use the Pythagoras Theorem as we did previously, right? So I'm just going to return, and I'm going to say math.sqrt, square root. And with that, I'm going to say y2 minus y1, all of that squared, plus x2 minus x1, all of that squared. So that will give us our distance. Now, the next challenge, or okay, let's actually rather get that, right? So over here, if we have 1 point, x1, y1, x2, y2. So I can say the distance between those 2 points, let distance is equal to get distance from x, y to xd, yd. Now we have a distance, right? And the biggest that this distance can be is the diameter of our circle, right? Because the largest length that could ever exist would go from one point on the far left all the way to there. But we want to somehow take that, right? Let's assume we do that, right? Our radius is 400, so that means we're going to get 800 as the longest possible point. We want to somehow take that and move that into something between 0 and 360, because that's the way that color is defined, right? This hue over here. We want to somehow take this distance and make our hue a function of this distance. So what we want to actually do is map the range of distance from 0 to 800 to 0 to 360, right? So currently we have 0 to 800. How do I get that into a range of 0 to 360? Luckily, we have a function in P5 that does that math for us. It's not very complicated math, it's just kind of percentages, but will be a good opportunity to learn something new. So if I say the following, I'm going to say let distance color, right? And what that is, or how I'd say that is, I can say map, right? So this is a P5 function. I'm going to put distance as our first argument. I'm then going to say, okay, map takes the range of this input, right? So we're going to go from 0 to radius times 2, because that's how big distance can go. It can go from 0 to radius of 2. It will then take that range and map it to 0 to 360. So that's what's happening. Let me make this a little bit bigger so it's all on one line. All that's happening is saying, okay, take this variable distance. This distance variable exists from 0 to radius times 2, and map each one of these values to 0 to 360. So now the smallest this can be is 0, and the biggest it can be is 360. And if I put stroke distance color instead, let's see the shape that we now get. Okay, and now we can see we're getting different colors kind of throughout this this thing, which I just find so cool. And what you'll notice is like you can see different like areas or different regions of color. In the middle over here, it looks very reddish, right? Because now these are the longest lines. If the lines exist in the middle over here, they're very long. If you go further out to the right or to the edges, you can see a blue kind of region, and then you get a green region. So you're visualizing the distance of all of these lines, which I just find so cool. So that's how we can take distance and map it onto a color. To find the angle that a point makes, right? So, or not a point makes, sorry, but rather a line. Imagine I had these 2 points. I had something at like 3, 2, and I had something over here, let's say, and that is -2, -1. If I have a line joining those 2 points, if I want to know, hey, what is this angle over here? The angle that's created between our x-axis and our line. What we can actually use here is very similar to polar, or thinking through this in like polar coordinates, or through using like circles, whatever it might be. Or actually, not even, right? Not even in this case. We're just going to use triangles. If I just draw a line down here and a line over here, right? I know over here is my y and over here is my x. Or the x, let's maybe use better labels for this. Let's call this height and this width, or whatever it might be. If this is a right angle triangle, and I want to get this angle over here, theta, I know that the tangent of theta is equal to h over w. Now, if we want to find kind of like this ratio of h over w, that's the same as our gradient, right? The gradient from this point to this point is going to be equal to the ratio of h over w. So we know if we're saying tan of theta, we're as well just saying what is also equal to the gradient of this line. Another way to look at that is delta y over delta x, right? Tan of theta. So if we want that angle, then theta is simply equal to the arctan of delta y. Ooh, delta y over delta x. So that delta y is simply from, very similar to the previous with distance. I draw a full triangle like that. There is my delta y from there, find another color. From there to there is my delta y. And my delta x is from here to here. There's my delta x. Oh, sorry, no, delta x will be all the way, not to the x-axis, but all the way from P1 to P2. Okay, so now that's how we can find the angle of a line given 2 points. So how could we do the same thing for the angle of the lines, right? So this is one way of visualizing things according to distance. Let's find a way to do this according to angle. So we've shown the math. To put that, we're going to make a function in order to find the angle. So I'm going to say function, I'm going to say get angle. And very similarly, I'm going to say x1, x2, oh no, sorry, x1, y1, x2, y2. Let's bring this a little bit further into the middle, okay? And what we're going to do is we're simply going to say return, and now there's a function in P5 called atan, which is arctan, and it's simply delta y over delta x. So let's actually make delta y, so delta y. We could do the same here, but let's be a little bit more, it's sometimes better to actually do this practice. So if anything, maybe I should have defined delta y for this, but we can say y2 minus y1, and let delta x is equal to x2 minus x1. And then I'm going to simply say like the arctan of delta y over delta x. Okay, so this then gets us our angle. And let's put this in here. So I'm going to say let angle, I'm going to say x comma y to xd comma yd, because we want to find that the angle of that line. Now we want to make it similarly, right? We want to take this angle now, and now if you know your tangent or your trigonometric functions, you know that tan goes from negative 90 to 90, right? That's the range or the domain of tan. We want to map that from negative 90 to 90 to 0 to 360. So very similar to distance color over here, I'm going to say let angle color. I'm going to say that is map. We're going to put angle. Oh, we can't actually use, what am I even doing here? I need to say, we can't actually use angle because we're using it over here already. We can say what's a variable I can give this? This is one of the hardest parts of programming, is just knowing what to label things. Let angle between, let's just call it angle between. Angle between, angle of line, line angle. Okay, that's a good word. Line angle. Okay, so we're finding the line angle between of the line that's created by these points. And then we're going to say let angle, oh, I'm already doing it. Let angle color, map angle color. It goes from negative 90 to 90. And we're going to map that to 0 to 360. And now instead of putting stroke distance color, I'm going to put angle color. And let's see what happens. Oh, we have an error. Let's see, cannot access angle color before. Oh, what am I saying? So yeah, not angle color, but line angle. We're mapping line angle, which goes from negative 90 to 90 to 0 to 360. And there we go. And now we get a completely different kind of shape that's forming. And as well, equally, if not just, I just love this stuff, man. It's honestly, you can see almost like a kind of star forming instead of like these regions. And now you can play, right? You can do so much more just with this. I don't know, if we wanted, say we took distance color, and instead of mapping it from 0 to 360, we mapped it from 0 to 100. And then we use distance color for our saturation value. So angle color, and I'm going to use distance color. And now we're using both the angle and the distance in order to visualize it. It might not be as nice. Yeah, you can kind of see it's like a little bit lighter, right? So towards the edges, things are a little bit lighter. What if we mixed it around? So we took distance color, we kept it 0 to 360. And instead we made angle color from 0 to 100. And then we made our stroke according to distance color, the hue according to distance color, and our angle color, our saturation value. And now let's see what happens. And we actually get like these moving regions all of a sudden now. You can see like these vertical lines which are forming. It almost seem to be like going across in different directions. So it's a cool time, man. But that would be that for multiplication circles and trying to play around with color and all this stuff. And you can see how we're able to use different principles of math from like the distance formula and like the angle of our gradient to create beauty. And this is the way math should be, right? Not 1,000,003 practice problems on finding the roots of parabolas or partial fractions, but making art. So let's carry on making art, and I'll see you in the next project.